What do you got?
That's okay.
What do you got?
We have a review for our next test.
Okay. So stuff you can
Yep.
verbalize?
Yep.
Okay. Go ahead.
Okay. So the first problem is at a recent Centennial High School dance performance, 93 people showed up. The tickets for adults sold for $4.50, and the tickets for children sold for $2.50, bringing in a total of $376.50. How many adults and children attended the dance performance?
All right. First step in any word problem is what? Always, everybody has difficulty with word problems. They really do. I've yet to find a student that doesn't hate them. But
Yeah.
I guarantee you it will be easier if you always start every single one by defining your variables. And
Okay.
you get that from the very last sentence. What's the last sentence say?
How many adults and children attended the dance performance?
There you go. That right there. So what's X going to be and what's Y going to be?
X can be adults and Y can be children.
Well, now you got to be a little careful with that because there's two things. There's the number of tickets sold and there's the price of a ticket. So they specifically asked for the number of tickets to adults.
Uh-huh.
That may seem like a subtle thing, but it's very important to spell out your variables almost as precisely as you can. And this is the
Okay.
number of tickets to children. And particularly in problems like this, because you do have a price per ticket and you have the number of tickets. So you can't just say X is number of adults
Okay.
or adults, because then it can get confusing. As long as you spell it out. Now, I need a couple of equations. I have two variables, so I'm going to need two equations. What's one equation?
Um, 4.5x,
Which is the revenue you get from all the adult tickets sold.
yeah, plus 2.5y equals 376.5.
Right? And that's one equation. We can't solve that on its own because it's one equation and two variables. So we need a second equation. What other equation do we have?
We can have
There were 93 tickets sold.
x plus y equals 93.
Uh-huh. Now becomes pretty straightforward. How do you solve that?
You could do either substitution or elimination.
Yeah. Which do you think would probably be easier?
Substitution, I think.
Maybe. Typically, when I see two equations that are both in perfectly standard format, in other words, where the x and the y are on the left and the numbers on the right, I'm inclined to use elimination just because elimination works so nicely in a lot of these.
Okay.
Hold on a minute. And I'll tell you why. In other words, if you're going to use substitution, then you got to solve one of these equations for one variable. Now, I could make x equal 93 minus y, and then go substitute, and then solve that. And maybe you're right. That might be the best way to do it. Or I could multiply the bottom equation by minus 2.5.
and eliminate y.
Yeah, I kind of
Okay.
like that better. So, and I'll show you. I think it's a little bit easier. Minus 2.5 there, minus 2.5 there, and I can multiply that by minus 2.5. Okay, the one thing I know for sure is that I'm going to eliminate a variable here.
Mm-hmm.
Now, it's not very often that my solution is to multiply by 2.5. Usually you're multiplying by integers in problems like this. You want to get rid of the fractions as quickly as possible, or the decimals. But notice that that's actually a pretty simple step to multiply by minus 2.5. It's going to eliminate y. What are we going to do now to those two equations?
What? Sorry, I didn't catch that.
What are we going to do now? Are we going to add or subtract these two equations?
I think we're going to add them together.
Right, we're going to add them. Okay, so what do I get for an answer?
2x equals 2,
do you have a calculator in front of you?
yeah, that's what I'm doing right now.
Yeah, go ahead and do that. I'll bet it comes out to a whole number.
Yeah, it does, I think. Minus 2, 2. Oh, 2x equals 144.
Okay.
So x equals 72.
Yeah. And which makes y equal what?
93 minus 72. 21.
Yeah, good. And to get the other variable, you're almost always going to go into the simplest equation, and the simplest equation is that one, the one that I used, the one that I multiplied by. In other words, okay, it's easier to solve for y from this equation here than it is either equation number 1 or the modified equation number 2. And okay, that's almost always the case. You're almost always going to want to go back into the equation before you multiplied. But the secret of these really isn't this. You know how to do this. You're going to get this right almost every time. The secret is setting it up. And the secret to setting it up is this part right here in the upper right. Always.
Okay.
And furthermore, in other words, when I see a word problem, I almost, in fact, I do sometimes, just start reading the last sentence first. The last sentence tells you how to define your variables, almost always. Not 100% of the time, but I would say 95% of the time. And once you've defined your variables, now you go back to the first sentence, and the first sentence tells you that x plus y equal 93, and the second sentence tells you that 4.5x plus 2.5y equals that.
Mm-hmm.
All right.
All right.
What else you got?
Next problem is, it says solve the system by method of substitution.
Okay.
The system is y equals x minus 4. And then the second equation is x plus 2 squared.
Quantity?
Yeah.
Okay.
Plus y squared equals 4.
Now, notice why this problem is better solved by substitution, because one of my equations is already solved for one variable. And it wouldn't matter whether it was x or y. As long as one of the equations is fully solved, well, it really lends itself to substitution. So I'm just going to substitute for y. Make sure you use parentheses when you do this. Just, if nothing else, it helps clarify it. Now, we've got to do a little bit of work here. What's the next line?
It would be, you'd multiply out x plus 2 squared and x minus 4 squared.
Do that, yes.
X squared plus.
Just do it term by term out loud so I can make sure you're doing it Right.
Okay, that's one. For the first one, I did x squared plus 4x plus 4,
Good.
and then plus x squared minus 8x plus 16
Good. And did
equals
you
4.
do that by foiling, or did you do it based on a plus b squared?
Foiling.
Okay. Here's something that it's really worth knowing right here. Whenever you square anything that's a plus b, you get a squared plus 2ab plus b squared. Okay? And
Okay.
whenever you square this, you get nearly the same thing. The only term that's different is the middle term sine. And the only reason I tell people they should memorize these is because you have to do it so often.
Okay.
You do. You're going to have to do it 1,000 times. So why foil it when you can do it this way? And in fact,
Okay.
I once saw a problem on a test that was the following. What is this result? And notice that, boy, even with a calculator, I bet you most people get that wrong.
Okay.
Okay, but if you know these two equations, you need to be able to go backwards as well as forwards. In other words, not only do you need to be able to square them, but you need to be able to recognize them squared.
Okay.
Okay, so can you recognize that?
Um,
Is that either this or this?
that's the bottom one.
Okay, so what is the a minus b? What's a?
10.
No? Remember, this is a squared. This
Oh, so it's 100.
100 is a. What's b?
99.
The answer to that is 1.
Okay.
Okay? And the only reason I bring that up is because that's something you're liable to see on the SAT in the non-calculator portion, but mainly to make your math easier. Because, like I said, you have to do this so with imaginary numbers. You know, have you had imaginary numbers?
Yeah.
Okay, well, if I had 2 plus I squared, I can do it a lot quicker using that than I can foiling it.
Mm-hmm.
Or if I had 3x plus 2y quantity squared, I could do it a lot faster using this than I could by foiling it. So that's why it's worth knowing these two.
Okay.
Just because you're going to have to do it so often, it saves time. And speed becomes everything when you take some of those tests. Now, let's finish this problem. How many total x squareds do we have?
2.
How many total x's do we have?
Minus 4x.
And the numbers?
Plus 20.
Okay. I can actually
Equals 4.
initially do that. So it's plus 16.
Yeah.
Equals 0. Now, the reason I want 0 on the other side is because this looks like a traditional quadratic. And whenever you're trying to solve a traditional quadratic, you put 0 on the other side. Now, what's the next step for solving this?
Factor it.
What's the first factoring operation?
Define the A.
Not quite. In other words, the very first thing you always look for when you're factoring something is greatest common factor. Is there a greatest common factor I can take out of that?
Yeah, 2.
Yeah, and it leaves a much simpler factoring problem. That's the beauty of always doing greatest common factor. At least I thought it left one. Okay. Now you can divide both sides by 2 and this 2 disappears. Okay?
Okay.
Now you have a what normally would be a simple quadratic. Now, minus 8 instead of plus 8 would be in good shape. Unfortunately, this is not going to be a simple quadratic. How are we going to do this?
We can use a quadratic.
Choices. We can use the quadratic formula. What's another choice? Complete the square.
Okay.
Okay. Do you know how to use the quadratic?
I know how to use the quadratic formula. Completing the square is kind of hard for me.
Let's do that then. That's why I was asking. If I'm going to complete the square, I want to move that 8 to the other side. So it becomes minus 8. Okay?
Okay.
Now, the way you complete the square is really rather straightforward. And this is, you just want to memorize the method, that's all. Okay? And you take half of this coefficient, the coefficient of the x term, and you square it. And you add it here. Always add. So what do I add there?
Add, let's see, 2x.
No, just half the coefficient. What's the coefficient is 2. Take half.
2, half 1. So you add 1?
Yeah. Okay. So I'm adding 1, and I can't just arbitrarily add 1. In other words, up until this point where I wrote in a 1 there, everything was exactly the same as it started. So if I add 1 here, I got to add 1 over here. Balance it out. Now, this is still exactly the same as that, exactly the same as that, exactly the same as that. Now, here's the beauty of completing the square, is I can now write this term. Because I completed the square, I can write it as a linear term squared.
Okay.
This becomes minus 7. And now, take the square root of both sides. So what's the next line? In other words, whenever you have a single item being squared on one side and a number on the other, well then the best way to solve it is to take the square root of both sides.
Okay.
So that's the square root of the left. What's the square root of the right?
It would be I square root 7.
Almost. Almost. You're very close.
Or square root 7i?
Well, no.
Plus, oh.
What I tell students is that whenever you're solving an equation by taking the square root of both sides, always your answer begins with plus or minus.
Okay.
And about 90% of students will leave that out. And critical error. You will lose points if you don't put the plus or minus there.
Okay.
Okay. You got the rest of it correct. It's root 7i.
Okay.
Now I'm moving the 1 over and I'm going to put it in front. And the reason I do is because this answer is going to look exactly like what you'd get had you used the quadratic formula.
Okay.
Now it's questionable as to which one is easier. Completing the square is something you have to learn at some point because it's not just for these problems where you have to be able to complete the square. Completing the square is vital if they tell you to turn standard format into vertex format. That's a completing the square problem, always. If they tell you to turn a long polynomial into either a circle, a parabola, an ellipse, or a hyperbola, once you get into conic sections, those are all completing the square. So you're going to have to do a lot of completing the square. And that's why I prefer to go through this solution by completing the square. You'll notice real quick that if I solve that using the quadratic formula, let's see, it's 4 plus or minus the square root of 16 minus 4 times 2 times c. I'm doing it before I divided the 2 out, or that becomes 4. Okay, and then this number here is going to be minus 49.
Okay.
And you're going to end up with the same exact answer. It's not quite minus 49. It's going to be minus 49 times 4. Yeah, 8 times 16 is a big number. But anyway, you're going to end up, without wasting too much time doing it, with exactly the same answer.
Okay.
The one advantage of using the quadratic formula is that you never are going to forget the plus or minus. Right? Because that's part of, when you memorize the quadratic formula, that plus or minus is a big part of it.
Yeah.
And so you're always going to have that. But perhaps you can use that in a way so that you'll always put the plus or minus when you do it that way also.
Okay.
Because you know it's supposed to look, in other words, the quadratic formula was actually derived by completing the square, exactly by completing the square.
Okay.
Now, there is another situation that I should run by you, and that's, let's say I had this. Okay? Now, if I go to complete the square, first of all, you cannot complete the square until this coefficient is 1.
The leading coefficient?
Yeah, the x squared coefficient.
Okay.
That has to be 1. So if it has a coefficient, it has to be divided out. And it could be fractional. That might be 3/4. Then I got to factor out a 3/4. I made this one easy, so I can factor out a 3.
3.
Now here's the thing. Here's the thing. So far it's still exactly the same. Complete the square. What do I have to add here?
Plus 1.
Now, how much did I just add to the left side of the equation when I wrote that in there?
3.
Correct. So I have to add 3 over here, not 1. Okay. Now I get 3 times x minus 1 quantity squared equals 13. Divide both sides by 3 and finish the problem just like we did before. In other words, now take the square root of both sides. So the final answer on this one is x minus 1 equals plus or minus the square root of 13 over 3. Move the 1 over. Now, there is something a little strange. In other words, that would be your answer, but not quite. What's wrong with this answer?
There's a fraction being squared.
Well, this square root of 13 over 3 is the same as this. In other words, I could write that like that, right?
Yeah.
This is equal to what I just wrote. What's wrong with what I just wrote? You never ever want to give this as an answer in math. Why not?
Because you don't want to square root in the denominator?
Yes. That makes it the denominator irrational. Okay?
Okay.
You always want to try to have rational denominators. So we have to rationalize that. How do we rationalize it?
Multiply it by the denominator?
Multiply top and bottom by the denominator. I can't multiply just the denominator by root 3. That changes the value of that fraction. But if I multiply top and bottom, I end up with square root of 39 in top, and then the bottom is 3.
Okay.
And now I have a rational denominator. So that's the answer I want to put up here. Is
so plus the square root of 39 over 3?
Yeah. In other words, you don't ever want to have things like this even. Okay, square root of 1/2 is square root of 1 over square root of 2, which is 1 over root 2. That's problematic. That needs to be rationalized, and it becomes square root of 2 over 2. So that's the same number, but it's proper format.
Okay.
So always kind of keep that in mind whenever you see radicals of fractions. Make sure that that denominator, either if it has a perfect square, well then you're fine. In other words, if I was taking the square of 1/4, that would not be problematic. That's going to be 1 over 2.
Okay.
Because square root of 4 is a rational number. But anytime you have a radical that does not reduce to an integer, it is irrational. In other words, that's irrational, that's irrational, that's irrational, so forth and so on. If it does not reduce to an integer, not square root of 9, because that's 3, square root of 10, every single radical that does not reduce to a whole number is irrational. It needs to be rationalized if it's in the denominator.
Okay.
All right. What else?
Okay. Sorry, I'm just trying to decide which one I want to work on. Because I've got a couple that I'm like not shaky on. There's a couple that I am shaky on.
Okay,
So.
that's fine. I hope you don't mind if my doorbell rings and I run down and get a little candy. But
no worries.
I figured that's better than canceling the session tonight. But yeah, I live in the house, and they usually don't show up till 7, so I'm kind of thinking they won't show up in the next half hour, but who knows?
Oh, you're okay if they do. No worries.
Okay.
That's not a problem. Okay. Here's another one. X equals y squared and x equals y plus 2. And again, it's solve the system by method of substitution.
Yeah. Whenever you see something like this, where you have a variable equals something and the same variable equals something else, then...
You just set them equal to each other?
Yeah, exactly. That x is the same x. If x is equal to that and x is equal to that, then that has to be equal to that. So I got y squared has to be equal to y plus 2. And now, how do you solve that?
You take the y plus 2 and move it over to the left side, and it becomes y squared minus y minus 2.
Equals 0. Important.
Equals 0.
And then what? Can that be factored?
Yes.
Mm-hmm.
Y minus 2y plus 1.
Correct. So your solutions are what?
Your solutions are 2 and negative 1.
All right. Now, what's x? In other words,
so with this,
because you came up with 2 solutions for y, you're also going to have 2 solutions for x. When y equals 2, what does x equal to?
X can equal 4, and x can equal 1.
Yeah, and you could get those 2 from either of the 2 equations you gave me.
Okay.
You could get it from this one, you could get it from this one. Personally, I found the top one the easier one.
Yeah, that's the one
All
I
I had to do was square the number.
Mm-hmm.
All right, what else?
Okay.
Now, how do you list this solution? In other words, it is pertinent that the 4 goes with the 2 and the 1 goes with the minus 1. So I'm thinking you kind of have to list the solution. That's one solution, that's another solution. In other words,
okay.
Y equal 2, X equal 1 is not a solution. In other words, these are in pairs. This is one solution, this is a second solution.
Okay.
Okay.
Okay. This goes again to the partial fractions.
Okay.
So 10x plus 2 over x minus 1 times x squared plus x plus 1.
Which you'll notice is an irreducible quadratic.
Yeah.
First of all, how do we know that's an irreducible quadratic?
Because it does not factor, and it's plus and plus.
Well, yes and no. What the real definition of an irreducible quadratic is it has imaginary solutions.
Okay.
And the way to tell whether something has imaginary solutions is to analyze this thing, which is called the discriminant. And it has a name all to itself merely because it's so important to be able to know whether you have a quadratic that has real solutions or imaginary. If this number is negative, you have imaginary solutions. If it's positive, you have real solutions, and then that's not an irreducible quadratic. I might have to use the quadratic formula to factor it. But so what's b squared? B squared's 1 minus 4 times 1 times 1. That's negative 3.
Yeah.
That makes it an irreducible quadratic.
Okay.
If that turned out to be positive, well then we'd have to go ahead and use the quadratic formula to factor that.
Okay.
Okay? And if it's factorable, well, it makes all the difference in the world. Then we have an A, a B, and a C in 3 different terms. But if it's an irreducible quadratic, then we have A over x minus 1. What's the rest of
it? Plus bx plus c over x squared plus x plus 1.
Correct. Whenever you have an irreducible quadratic, you need the x and the c in the numerator.
Okay.
Now what?
Yeah. We multiply each of those fractions by each other. So you multiply a by x squared plus x plus 1. And you'd multiply b x plus c times x minus 1.
Yeah, in other words, you would do what you would do if you were going to add these two fractions together. And in fact, let's go ahead and put the common denominator so we know exactly what we're doing here. In other words, that's what I get if I add those two fractions together. I get this. Okay?
Okay.
Since the denominator is the same as this denominator, then I can equate numerators. In other words, the numerator has to equal this numerator. I'll just erase my denominator so it doesn't confuse the issue. And now we just have to solve this.
Okay.
Next step.
You multiply the terms you multiply them by each other.
Yeah,
so it becomes.
That's one way to do it.
Or you could do that thing where you.
Let me think for a moment whether that's going to work. We can certainly eliminate this term by letting x equal 1. And then we would have 3a equals 12. So that would solve for a. But then solving for b and c are going to be a little tough. Okay.
Yeah.
So, let me think for a second. Well, let's try it both ways and see which way is easiest.
Okay.
Ax squared plus ax plus a plus bx squared minus bx plus cx minus c. All of that has to equal 10x plus 2. And what's the next step?
Oh, there goes my alarm.
Ah,
Sorry, that's my doorbell.
okay. Do you have to get it?
No, that's my mom gonna get it real quick. Sorry about that.
That probably means mine's going to start going off here pretty soon also. But
hmm
okay, so what's the next step on the right side?
To combine like terms.
Okay, so combine like terms and factor. In other words, I got an ax squared and I got a bx squared. So that's going to be a plus bx squared, right? In other
Yeah.
words, think of factoring out the x squared, leaving behind a plus b. The only thing is I'm going to write it in front. So that's the coefficient of x squared, okay?
Okay.
What do you got when you combine all the x's and factor
Plus
out?
a minus b plus c
Okay, I'm taking
equals
x
x.
out. Oh, hold on. I should have written it as you were saying. You were ahead of me.
Huh.
You
No worries.
were way ahead of me. So it's a minus b plus c times x. And finally, what kind of a constant do we have?
Plus a minus c.
I'm going to put that in parentheses, just for illustration purposes. Now, let's start coming up with some simultaneous equations, because these kind of things usually come down to that. What can I say about a plus b?
A plus b is equal to 0.
Okay. What can I say about a minus b plus c?
A minus b plus c is equal to 10.
And a minus c is equal to
2.
So first of all, I know that, let's see, I got 3 equations and 3 unknowns here. So I know I can solve them.
Okay, so c, a is equal to 2 plus c.
Okay, that's one way to go. I can certainly do that, and then I can substitute that wherever I see a.
Yeah.
That's going to get rid of all the a's, and then I'm going to have 2 equations and 2 unknowns. So that's
Should we do substitution or should we do elimination?
Well, what I was looking at is if I add those 2 equations, the b disappears.
Yeah, and if you add the bottom ones, the c disappears.
Yeah, that's got to be the way to go. And when I have 3 equations and 3 unknowns, like this, especially, again, if it's in standard format, as these are, all the variables are on the left, all the numbers are on the right, I think elimination is almost always the best way to go.
The better way to go.
So my equation 4, which is going to be missing a b,
becomes 2a plus c equals 10.
Yeah, now here's the thing. When you do equation 5, you got to make sure you eliminate the same variable. And I can't do that.
Isn't that already eliminated though?
No. In other words, I've got to come up with 2 equations and 2 unknowns in order to solve this problem. And if I number this 1, 2, and 3, and now I go and add 2 and 3 together, C goes away, but now I have an A and a B.
Oh, I see.
So now we end up with 2 equations and still 3 unknowns.
But are you not allowed to just add 3 and 4 together?
That's correct. You're not. Well, yeah. First of all, you got to create 4 and 5. Both of them missing the same variable.
You could use A for a missing variable, right?
Yeah, let's eliminate A because I can use any 2 equations, but to create equation 5, I have to use 2 different ones than I used to create equation 4. But you're on the right track. I'm going to be able to eliminate A from equation 4 and from equation 5. How do I eliminate it from equation 4? What do I have to do?
You could do negative a minus b equals 0, and you could add it to, you add equation 1.
Subtract. In other words, you're allowed to subtract equations just like adding equations.
Okay.
And I already have a plus a there and a plus a here, so let's just subtract 2 from 1.
Okay, so
what am I left with? I've got equation 1 minus equation 2. How many b's do I have?
2 b's, 2 negative b's.
Not negative. In other words,
positive.
Sorry. 1b minus a minus 1b. That's a plus 2b.
Yeah.
And then I got no c's minus.
So it's a minus
c.
c.
So that's a minus, and that's equal to minus 10.
Okay.
Now equation 5, I got to eliminate a. Well, let's eliminate a. I can either use 1 and 3 or 2 and 3, which is simpler.
2 and 3?
Well, actually 1 and 3. 1
1 and 3
terms, and 3 only has 2 terms.
Okay.
So subtract 3 from 1.
You get, subtract 3 from 1. You get b plus c equals negative 2.
Yeah. Now notice I've got 2 equations and the same 2 variables.
Okay.
And now I can solve this system of 2 equations and 2 variables and then work my way backwards to solve all 3 variables. And this one actually solves rather nicely.
Yeah. So it becomes 3b equals negative 12, and b will equal negative 4.
Is that on your end? I think it was. That doorbell?
Yeah, that was.
Okay, so now we solve for minus b. What's the next variable we can solve for?
We could put b in for equation 5 and solve for c.
Okay, so c is equal to what?
C is equal to negative 4 plus 4. C is equal to 2.
Okay. Now I got b and c. I got to get a. Which equation is the easiest one to get a?
The top one?
Probably, yeah. A has to be minus 2, right?
Yeah.
And there's your 3 solutions. Now, this was kind of an interesting problem because they almost set a trap here. In other words, it's so easy to cancel B, and it's so easy to cancel C. But if you do either of those, you can't cancel it from equation 5. It's not there to be canceled anymore. So this one, I think you really need to cancel A in fourth and fifth step. But this is pretty much always the way it goes here. Now, would substitution is certainly going to work. I could make that A equal 2 plus C.
Yeah, but this one they let you just do it however you want it.
Okay, cool.
Whatever
I won't waste time going through the substitution. I think you know how to do the substitution method anyway. But I would just advise that whenever you see all your equations in standard format, elimination might be a little easier. Substitution can get pretty brutal if you have an awful lot of variables on there. I guess. I don't know. I think that's probably just an individual choice. But you want to know how to be able to do this by elimination also, if you weren't, if you didn't know. Okay. And let's see. Okay, I guess we've solved for all the variables, and now we know what A, B, and C are. And,
and now you just plug them back into
if your life depended on it, you might want to substitute A, B, and C in and add these two fractions together and make sure you get that in your numerator.
Yeah.
You know what I mean? If taking a test that's being timed and you don't have time to do that, then it's probably just good to have faith in your answer and go to the next problem. But all right, what else you got?
Okay, one more. Y equals x minus 1, and y equals x minus 3 quantity cubed.
So what's my first step?
Set them equal to each other.
Huh? Yeah.
Second step would be to...
I'm going to assume every time I hear it like that, it's yours. Mine's
I'm sorry.
Mine's not going to be that loud. It's 30 feet away. But okay. So now what?
Now we have to FOIL out the x minus 3 cubed.
So I don't think there's a way around that. Yeah, taking the cube root of each side doesn't work. So here's the way I like to do it. Do the last two first, creating a trinomial, and then multiply that trinomial by this initial binomial. So here's another situation where you're taking something and squaring it. So you do it quickly. What is it?
X minus 6x plus 9.
X squared minus 6x plus 9.
Oh, x squared, sorry.
That's okay. I want to get you used to doing it quickly, even if you make a few mistakes at first. That's fine. Now multiply that binomial by this trinomial. And I found that it's just a little bit easier if you have the binomial first and the trinomial second rather than reversed. And that's why I always multiply those two together first. Now, what does that give me over here?
X cubed, oh wow, it's going to be a little big. X cubed minus 6x squared plus 9x minus 3x squared minus 18 plus 18x minus 27x or minus 27.
Correct. Now, whenever you do one of these multiplications, there's only going to be one of those, and there's only going to be one number. In other words, your end terms are you're never going to be combining those with anything else. And pretty much everything in the middle will be combined. Not all into one term, but we've got some x squareds there, and we got some x's there. So I guess all I'm trying to say is you don't need to search for any more x cubes. Okay, how many x squareds do we have?
Negative 9x squared.
And x's?
Plus 27x minus 27.
Okay.
Boys always take more candy.
My mom's mad because boys are taking more candy.
Yeah. More than the girls? That's funny.
Yeah.
Now notice this one does not solve by grouping. You have a cubic here. And remember, in order to solve by grouping, the ratio of the coefficients of the first two terms has to be exactly the same as the ratio of the coefficients of the last two terms. Well, this is minus 1 over here. This is 1/9, minus 1/9. So we cannot solve it by grouping. The fact that they gave you this problem, you were supposed to solve it all the way for x?
Yeah, but I'm kind of confused because...
you had the rational factor theorem and the zero remainder theorem?
Yeah.
Okay, well that's the only way to solve it, unless you're allowed to solve this with a calculator.
Yeah, but she just said she wanted us to get the quadratic equation on this, so actually, or the cubic equation, so I think that's actually the end.
There is no, oh, I see. Okay, she didn't want you to solve for the zeros?
No.
Okay. You could put that into your calculator and find the zeros. That's one way to do it. That's an easy way to do it.
And this test is a calculator test, so I think that's why she didn't really want us to.
Okay. Because if we have to do this by hand, well, we're looking at a P over Q situation, and P are all factors of 27, so it's plus or minus 27, plus or minus 1, plus or minus 9 plus or minus 3.
Yeah.
That's all of our possible answers, because Q is just plus or minus 1.
Mm-hmm.
Q is the coefficients of the x cubed term. Okay? And then the way you find a 0 is to randomly divide this polynomial using synthetic division. Now, I always start with the smallest number, plus 1. If that doesn't work, minus 1. You keep dividing until you get a 0 remainder.
Okay.
Once you get a 0 remainder, that means the term that you divided by is a 0. And as soon as you have
Okay.
1 0, then you reduce everything else to a quadratic. And once you get it down to a quadratic, then you can always use the quadratic formula.
Okay. I think I know how to do that, yeah. I actually know how to do that.
What I forgot to do here, it just occurred to me.
Yeah.
We added the left, but we didn't bring over the x minus 1.
Oh, so we need to bring that over real quick.
Yeah, which means that becomes 26x, and this becomes 26.
28.
I think 20, let's see, it goes from...
Oh, no, 26, yeah.
1, yeah. So this is actually going to be the cubic. And then it just changes all of that, because P, the factors of 26, are different than the factors of 27.
Yeah, that's okay, though. I understand that.
Okay, good. I didn't know it. In other words, I kind of got caught up in
That's okay. I didn't notice it either.
expanding this, and I forgot to combine it. In other words, you still need to make 0 on one side and turn it into a cubic equation with 0 on the other side. No matter what degree polynomial you have, that's really the only way to solve them, is to put 0 on one side.
Okay.
Okay.
Well, that's the extent of my problems tonight.
Okay. Well, cool.
Thank you.
Happy Halloween. And
oh, wait. My mom has one question real quick. Sorry.
Yeah.
Sorry, David. I needed to. I want to pay you, and I just don't know how to do it because I don't see you in
Send a check, or you want to pay by PayPal?
PayPal would be great. That way you'd have it instantly. Or do you have to pay a percentage on that?
I got to pay, but I don't mind that. Here, let me show you.
Are you sure?
Yeah, let me show you exactly how to use PayPal. I'm going to go to my website. It's real easy. Let's see if I go to Digital Math Tutor. Yeah, I got to find my website. There it is. That's the one to go to. This one's easier than algebra to calculus if you're going to use PayPal. Okay.
Oh, okay.
Okay, and scroll down and hit the Buy Now button. You'll see exactly how it unfolds. When you hit the Buy Now button, it's going to pop up a screen where you put the amount in, price per item, and I'm just going to put in $1 to demonstrate, and and it pops open, and only you see this next page, which is the login information for PayPal.
Okay.
And
all right.
With the login information in, now it pays it automatically. And I think that's all you have to do is put your password in, log in, boom, you're done.
Okay. Does Nicholas have a password?
I'm sorry. Are you talking to me?
Yeah, I don't have a PayPal account. So would I just log in as a guest?
You need to open a PayPal account and fund it.
Oh, gotcha.
So
okay.
That might be more difficult for you. If you want to send a check,
yeah.
let me put my address up here. So you know where it's, make it to David Cowan.
Okay.
Not my company. And my address is 7320 Quarry Mountain. You guys live on a mountain, don't you?
We do. We live on Dakin Mountain.
Yeah, I thought so. There's not that many people that live on mountains, huh?
I know, and then people, when you go traveling, they're like, you live near a mountain? It's like, not really.
Well, what everybody always asks me is that street or avenue?
Oh, there
Quarry
you go.
Mountain Street or Quarry Mountain Avenue? It's Quarry Mountain.
That's funny.
Yeah.
Okay, so I'm just going to pop you in a check for this week and last week.
That's fine.
So then we'll be up to speed there.
Okay.
Okay, 7320 Quarry Mountain, Little Tornado 127. Perfect. Great. Thank you so much. I appreciate it.
Thank you, Mr. Conner.
You're welcome, Nick.
We always say your last name wrong. I'm so sorry.
It's Cowan. Yes, that's
Cowan. We got to remember that, Nick.
Okay.
So, okay.
Mispronounce my name. That's fine. So, all right, Nikki, I will talk to you guys on, let's see, we're set for Thursday, I believe, right?
Right. And then I got to book a few more after that. So
Thursday at 4.
we'll be good. Great. Thank you so much.
Thank you. Happy Halloween.
Yeah, you too. Bye-bye.
Okay. Bye-bye.